Okay, so obviously you're back for more of my amazing drawings. As you can see, my pyramids. That's obviously the only reason why you keep coming back is for these artistic expressions in math. But let's just take a look at this question. So they gave us two pyramids, and they say, hey, these pyramids have these volumes. So the one has a volume of 2072.25, and the other has a volume of 614. And the height of the smaller one is 3.5, and the height of the bigger one is which is unknown. Now, when I see this question and they say, hey, these are similar shapes, I have to compare two things that I can compare. And in this case, I can compare the volumes because they're both given. I can't compare anything else because nothing else is given. So what I do is I'll just take the bigger number, which is 2072.25, and I'll divide it by the smaller number, 614. And I can keep this in my calculator, but I think this does reduce to something nicer. If I, let me just see what happens here. Divided by 614, and then I get something like 27/8. Very convenient, but obviously. So now this is the scale factor for volume. So this is my volume scale factor, which I should remember. And I can't use my volume scale factor for this because this is length. They want the height of something, which would be measured. That's a length measurement. So in order for me to use this scale factor, well, I can't use it. I have to change it a little bit, and I have to get to length. So to get from volume to length, I have to take the cube root. Now, very conveniently, if I take the cube root, so if I want the length scale factor, that would be the cube root of my 27/8, and that would just be 3/2, if I'm not mistaken. Let me just double check. Answer. There we go, 3/2, yeah, because 3 times 3 times 3 is 27, 2 times 2 times 2 is 8. Very convenient in this case. But even if it wasn't such a nice number, I could have just wrote this and cube root this whole thing. So I'm going to write that, but let's just see what do I need to write next. So because this is given, I can start with this, so 3.5. And because I'm going from a smaller shape to a bigger shape, because obviously this is the smaller volume and that's the bigger volume, I'm going to have to multiply. And now I can multiply with this. Or if I was just too lazy, I could just do this whole thing of like 2072.25 over 6.1, well, 6, not 6.14, 614. And that would have given me exactly the same answer. So let's just say 3.5 multiplied by a very big weird number cubed, and that would just give me 5.25. So the height here would be 5.25. So let's just recap what we did. We compared volumes to get a volume scale factor, and then we took that volume scale factor and we changed it into a length scale factor by taking the cube root, and we just use that new scale factor, which is the length scale factor, and we worked out the length of the shape, well, the height in this case.